So my topic today is automatic driver identification to build predictive analytical solutions. So people talk about big data and big data analytics, and especially the predictive analytics. Very popular, right? But then when you specifically started engaging the building models, it's not that trivial. So today we will share some lights. And then we build the solutions through a concrete enterprise engagement in our company. So we want to build predictive solutions for our company's revenue at all business units, all geographical locations. Okay, that's a very kind of ambitious objective, but then we did it. Here is quite a simple introduction. First, we want to create best-in-the-class predictive models. So shortly, you will see why we claim to be best in the class. We will have some criteria. The second, okay, the scope for this engagement. We want to predict PC revenue for multiple business units, specifically for PSG. PSG stands for Personal System Group. Okay, that's the core business for printers, for PCs. And all regions and all business segments. So basically, when we talk about business segment for PCs, you have three. So desktop, laptop, and the tablets, or mobile, okay, that kind of stuff. And then for PSG, we also include the printers and the print consumables. So probably as a consumer, you probably know, okay, so you have a printer and you also buy ink, buy paper, use paper and print ink. We call it consumables. We want to predict their demand and the revenue. And the initial focus for this engagement was focused on PC. And we want to have a specific target, short-term forecasting, meaning from 1 month to 3 months. And then once we build confidence and credibility, we want to expand into a longer range forecasting. So earlier I mentioned we want to build the best in the class solution, right? So you need to have some criteria. So the first capability and objective here we specify is data-driven model. Okay. So in many companies nowadays even, people have manual process, spreadsheet-based, even some data-driven models, but then mostly not that sophisticated. Okay. So we were very clear at the very beginning. We want to build a model-driven, data-driven model to predict monthly and quarterly revenue. So the aggregation is monthly and quarterly. The horizons I mentioned, okay, so short term, 1 to 3 months, but then down the road we want to expand to multiple months and multiple quarters. And then the models aim to capture effects in 360-degree situation. Okay, the first is around the time dimension. So we all know in the time dimension you have seasonality, you have seasonal effects. Okay, so we call it related to seasonality, but the short-term seasonality and long-term seasonality. Okay, and then you also have trend, short-term and long-term trend effects. And then also related is the event-related effects. So that's all around the time dimension. But then we want to capture much more. Okay, we want to capture the effects from microeconomic leading indicators. Okay, so there are so many. Okay, we will give a core list that we analyzed. And then we want to capture effects around the revenue stream. Since we are predicting revenue, definitely you want to have a good knowledge and modeling effects captured around the revenue stream. So in this case, the shipment, first the order, then shipment, and then revenue recognized. So in between each stream, okay, so there is a lag time. So customers place an order first, and then you ship. So that lag time actually can help you to do forecasting. And then once you ship, you wait for a little while. Okay, well, after the goods arrived at the customer's door, okay, through the proper recognition, and then you can recognize revenue. So there is another lag. Okay, so 2 lags to our advantage. And then also the effects surrounding the other business drivers, okay, such as channel inventory. Okay, so you sell through Costco, you sell Best Buy, whatever channel. Okay, so you will know, okay, what is the inventory at this stage. Okay, and then for instance, okay, sales through and the weeks of supply, that kind of quantities. Now, earlier I mentioned, again, I want to emphasize the best in class practice. And then here we have a specific list. First, whenever you do forecasting, predictive analytics, you want to have kind of similar rules of thumb or criteria or rules, okay? The first is the purpose. You need to be very clear about your predictive analytics purpose. In our case, okay, so we want to contribute the HP's overall capability to develop plans. Okay, the plans cover the financial plan and production plan. So reasons for developing forecasting, okay, that's very important. The second is subject. What subject are you forecasting? So in our case, revenue, right? Very clear. So why you want to be very clear about the subject you want to forecast? Because you want to be clear about the surrounding streams, data streams. Okay, I mentioned earlier, revenue, the surrounding streams, order shipment. So if you are forecasting something, you need to be very clear about your subject, and then you can easily identify the surrounding streams. The third element is time horizon. So 1 day, 1 week, 1 month, 1 quarter, all different. Short-term forecasting in general, easier. Okay, long-term forecasting, you need to identify long-term drivers. It's not easy. Level of details. You want to forecast at the company enterprise level or at the GBU level, global business unit level, or for a specific region. Or yeah, so you can have a kind of a hierarchical structure there. And then again, you need to be specified. Scenario. So when we talk about the predictive analytics or forecasting, some people think, okay, there is a crystal ball or kind of a smarter software. True. Okay, crystal ball, not necessarily, but the smarter software in certain sense, true. But then there are always assumptions built upon the methodologies, the tools behind. So we need to be very clear, okay, as an analyst, as a model consumer, okay, you need to be very clear about the assumptions behind. In our case, because we build a set of models, I just give 3 instances here. Okay, first is the kind of seasonal, the time series enhanced forecasting. We will shed more light shortly. So in there, we assume seniority is established in the last 3 years, and the trend is established in the last 6 months. Of course, those parameter values you can change in your model, but then we analyze the different values, and we come up with this suggestion. The second assumption is macroeconomic leading indicators. You have many, okay, you identify a subset. Okay, those leading indicators are also the social media data nowadays we incorporate. Need to reflect the demand in PC, in our case, right? So especially social media, okay, if you look at some kind of social media sites, and then people comment positively, negatively from time to time, okay? And then you cannot be driven by that kind of instant up and down, okay? So there is an assumption there. The third set of models is the business drivers. Okay, we assume the business drivers can be identified, quantified, and modeled. Okay, sometimes you know conceptually a driver exists, but then if the data or quality data is not there, still, okay, you cannot accomplish much. The next criteria is the frequency. How often you want to have your forecast updated? Weekly, monthly, or whatever. Okay, in our case, we have a kind of a weekly updating process. Okay, manual process. But then once we got this solution up and running, we can have the updating them on a daily basis. And the last but not least is the participation. So you have a bunch of analysts, okay, and then business field managers engaged with this kind of predictive analytics. Good. Okay, the tool can reside in a finance section. But then really you need to have a widespread and in-depth involvement and participation from all the people around. Business managers can help you define a scope and define the surrounding metrics. And the financial people definitely they know how the revenue, for instance, the revenue is recognized, the time lag, etc. Economists can help you or get a better view about the global economy, the US economy, etc. So you need to have widespread participation. So those 7 criteria we set at the very beginning. We followed a book by David Axon, The Best Practice in Financial in Planning. Okay, you can get it from Google, from Amazon, very easy. Okay, but then we followed that set of criteria. Now, let me say some words about microeconomic leading indicators. So we wanted to have a 360-degree coverage for all the economic perspective. So you can see on the left panel, okay, you have categories. And the right panel, you have specific examples for each category. For instance, okay, employment, definitely, okay, you can see the unemployment rate. So back to the financial crisis a few years ago, the unemployment rate was high teens. Okay, now, okay, of course, about maybe 5 or below. Yeah, so those numbers, okay, definitely reflect the whole economy in the US and on the globe. And then since we are focusing on PC, you also look at the PC consumer behavior. For instance, okay, the consumer spending and confidence, conceptually very related, right? You can also check down the road, okay, the correlation, the tempered correlation or the lagged correlation, etc. The inventories, okay, and the housing and the construction, surprisingly, also very relevant. Okay? And then the foreign trade, price, productivity, etc. You can see a comprehensive list. Now, we get down to technical details, the modeling techniques for driver identification. First set of solution. So on the x-axis, you have in here from 0, 1 to 12. So this is for monthly aggregation. Y-axis is basically minus 1 to plus 1 is the correlation magnitude, the limit. So we have multiple colors for different curves. So let's focus on the first curve, okay? So green, I have put a label, okay? That label is 0, okay? So this is revenue. What does that mean? So revenue with itself, the correlation, okay? Lag 0, meaning the revenue with itself with no lags, of course, 100% correlated. So this point at lag 1, meaning this month's revenue versus previous month's revenue. Okay, you can see a very negative correlation. Okay. If a correlation magnitude is around 0, of course, with certain confidence interval are quantified, then that means it's not a linear correlate. But in this case, you can see at lag 1 month apart, strongly negative correlate. At month 2 apart, also strongly correlated, negative correlate. But if you go to 3 months apart, okay, and again, you can see very strongly positively correlated. So what does that mean? So companies like in HP, okay, many other companies, so same, okay, you have fiscal quarters. So you compare your sales the first month in your fiscal quarter versus the first month in your previous fiscal quarter. Not sequential comparison, but quarter over quarter or year over year comparison. That's why, okay, you got this kind of 3 month cycle. Okay, in the revenue itself. Okay, also from this graph, you can see very strong. Now let's move on very quickly, go to the second yellow curve. This is America's, remember we mentioned the specific region and GDU, IPG. Okay, so this particular metric, okay, you can see the yellow, and then at lag 0, okay, some correlation, I cannot see very clear here, and then you can see, okay, the curve here. Also, it has some kind of quarterly cycles, but not as strong as the revenue itself. So with other metrics, same thing. So now, for each variable, or we call it candidate driver or variable, you identify the most important lag. For instance, okay, so for the red curve, okay, you can see red is the US-Canada merchant import in millions of dollars. That's candidate drivers. So that, it tells you at lag 1, okay, you can see there is a circle for 2, the curve 2. So I put a circle means, it means, okay, at this lag, it is most significant. So that means, okay, for US-Canada merchants imports is most significantly correlated with HP's revenue for PC sales in this region for this business at lag 1. So it tells you what drivers, candidate drivers, are important at what lags. So a simple graph like this, implemented in R, okay, you can get a lot. So for other drivers, same thing. Okay, of course, it has numerical, you can see numerical illustration, and then also numerical, other graphical illustration, and then numerical values. For scale 1, 0.3, minus 0.3, etc. So the second method is based on a decision tree, random forest method. So again, you have all the candidate drivers and the candidate lags. So in our case, we specify the candidate lags from 0 to say 3 or 6, something like that. Okay, and then candidate drivers, you can have an initial list by the correlation method. Now you can see here. So based on the importance of the random forest method output, you can see American's IPG for this particular business combination. Okay, the sales through metric at lag 1, most important. And the second is revenue itself at lag 3. Earlier, when we examined the serial correlation, we also see that. Okay, revenue at lag 3, most significant. So now, with those kind of methods combined, okay, you can get a collective vote, and we use that collective vote as a mechanism to for variable identification. So now we got that set of drivers, of course, dynamic drivers in this case. And then we build a time series enhanced regression model. Okay, so the framework is time series, but then you have specific regressors or explainative variables, properly lagged. And then let me explain very quickly. So x-axis is the calendar months. Y-axis is revenue in millions of US dollars. Okay. The black curve is the historical actual. And then we use historical data and the estimated values for certain drivers we project into this future. In this case, 6 months. You can see. So we withhold some historical data and we project for those 6 months period. The green curve is the point projection. The other two curves are the confidence interval projections. So the confidence level you can set, for instance, our CFO wanted to be more conservative to external reporting, so 95%. And then for internal reporting, you can be more aggressive, 80% or 85%. But anyway, so you can see, okay, so our cross-validation results, and you can see for each month after month, the forecast error, the accuracy. And then with the future months, of course, you don't know the actuals, you can output the real forecast numbers. So earlier I mentioned the terminology, time series enhanced models. So here we have two enhancements. One, of course, the dynamic regression. The other enhancement is usually when you have historic data, you get that, and then you immediately clean up the data and build the models. So that's not good enough. Why? Because remember, okay, earlier I mentioned the financial crisis. Okay, if you use data prior to financial crisis for financial crisis, so there was a economic structure change. Everything changed afterwards. If you include the data, even if the data quality was still good, okay, if you include that, that can be very problematic. So we developed a solution called the change point detection. So that solution can automatically identify the structural change time points. And then with that, you exclude any points, okay, prior to your structure change time points. And they only use basically relevant data points to build the models. So that's the two enhancements. So enhance the time series models to forecast at monthly level. Actually, we also have quarterly level, etc. The models incorporate influencing factors. Definitely, you need to be very selective. Okay, but on the other hand, you want to be comprehensive. That's why I used the terminology 360-degree coverage. So macroeconomic factors, business drivers, even social media data. Okay, you get all of them into your model selection module. And then let the module decide what driver factors are really relevant and important. And then we also have developed some modules around the way for the solution. So first, okay, the spatial and the temporal correlation that you already see. Okay, time series similarity-based driver identification. So earlier we talked about the correlation, right? But then there is another method. Okay, so you have a graph, basically it's a time series revenue, and then another graph is your candidate driver time series, and then how similar they are. Maybe okay, they got a shift, but then some overall kind of pattern more or less the same. So you have a strong similarity. So we use that similarity measure to derive to select drivers. So I didn't include the slides here, but then that's another method. Of course, decision tree method. Okay, so decision tree method. Okay, let me see a couple of words very quickly. Okay, so the random forest method basically assumes the distribution is kind of Gaussian distribution, and then you can replace with you can sample with replacement. But in time series, here we are talking about the time series data. So time series data, if you do the sampling, you will lose the time series structure. That's a very important issue. Okay, so we take care of that. So we've developed proper sampling methods to sample the time series elements. So basically keep the time series structure intact. Then you can have assemble to make the decision tree. So and the last one, but not least, empirical-based seniority. So earlier I mentioned the seniority. Actually, when we talk about seniority, you have multiple layers of seniority. You have quarterly, you have yearly, sometimes you also have half-yearly. Okay, so empirical evidence can help you, of course. So field experience can help you, but then we develop a solution, again, data-driven. That data-driven solution can help you automatically identify, okay, what is the seniority based on the resulted forecast accuracy. So you can test the forecast accuracy, and then, say, 3 months is the best, or 1 year is the best. Yeah. So basically that concludes my presentation. Any questions?